Hey guys, so today we're going to talk about our second way to solve a system of equations, and that is using elimination. So first, let's title it Systems Elimination. That's our second strategy. All right, so let's take a look at our first example. So our first system is negative 3x minus 3y equals negative 24, and 12x minus 6y equals negative 12. So just like the strategy says, we want to try to find a way to eliminate either the x or the y, because remember, the goal of solving a system of equations is to find the point x and y that will make both equations true. And so let's look. So look at our x's. On our x coefficients, we have negative 3x and 12x. And for our y coefficients, we have negative 3y and negative 6y. So what you want is you want opposite coefficients. So I like looking at our x's because I have a negative and a positive. Now, if you'll remember back whenever we studied how to eliminate fractions and decimals, we multiplied by something, both sides of the equation by something. So that's what we're doing here. So in this situation, I'm going to multiply everything on the top equation by 4. And what that's going to do, watch this. 4 times negative 3x is negative 12x. 4 times negative 3y is negative 12y equals, and negative 24 times 3, so I know it's going to be negative, and 24 times 3 is 72. So now watch what happens. Now, when I combine all of these, 12x minus 12x cancels. Negative 6y minus 12y equals negative 18y equals negative 12 minus 72 is negative 84. Now I'm just going to continue solving equations the way I'm used to. So y equals, and I'm going to do 84 divided by 12 is 7, double negative signs is positive. So now I have my y of my point where they cross. So I can go back to either of my two original problems and plug it in. I'm going to go back to the very first one. Negative 3x minus 3y equals negative 24. Well, we said y was 7. So negative 3x minus 3 times 7 equals negative 24. Negative 3x minus 21 equals negative 24. I'm going to add 21 to both sides. So I get negative 3x equals negative 3. Divide both sides by negative 3, so x equals 1. So what that means is these two equations cross or intersect at the point 1, 7, because my x value is 1 and my y value is 7. So that's how we use elimination to solve a system. Let's try several more examples. So example 2. So first I'm going to write the system. Negative 8x plus 2y equals 8. And I have 4x plus 8y equals negative 4. Remember, I want to eliminate or get rid of either the x or the y. I notice that my x's, I have a negative 8 and a negative or a positive 4, so those are opposites. And then for my y's, I have 2y and 8y. Guys, it doesn't matter which one you eliminate first. You get to choose. I like the x's because they're opposite signs already. So I'm going to multiply the bottom by 2, everything by 2, because what that will do is that'll give me a negative 8x plus 8x. My x's will cancel. So I'm going to rewrite this. Negative 8x plus 2y equals 8. Now let's do the distributive property. 2 times 4x is 8x. 2 times 8y is 16y. And negative 4 times positive 2 is negative 8. So let's combine these two equations. So the x's cancel. 2y plus 16y is 18y equals 8 minus 8 is 0. It's okay if we have 0, okay? So now I'm going to divide both sides by 18. So y equals 0 divided by 18 is 0. So I have my y value. Now I go back and pick one of the original equations. It doesn't matter which one. I usually just stick to the top one. So negative 8x plus 2y equals 8. Well, we found out that our y was 0. So negative 8x plus 2 times 0 equals 8. See, I'm substituting that 0 in for the y. Negative 8x, well, 2 times 0 is 0. So I'm just going to leave that alone, or not even write it. Divide both sides by negative 8. So x equals 8 divided by negative 8 is negative 1. So the point where these two lines cross is negative 1, comma, 0. So that is the solution to that system. Now let's take a look at those special cases. So just as a reminder, if we had, in our last lesson when we graphed, if we had two parallel lines, there was no solution. And if we graphed it and ended up with the same line, there were infinite solutions, or infinitely many solutions. So let's see what those look like using elimination. So let's take a look at this example. This will be example 3. So let's write our system. Negative 18x plus 14y equals 2. 9x minus 7y equals negative 10. So looking at this, both my x and my y are opposites. So I'm going to multiply the bottom by 2. And the reason I chose 2 is 2 times 9x will give me negative 18x. But watch what happens. Let's go ahead and rewrite everything. So the top one is negative 18x plus 14y equals 2. And the bottom, you're going to get 18x. 2 times negative 7y is negative 14y equals, and 2 times negative 10 is negative 20. Let's combine. Oh, I do not know why I put parentheses on that. Because I already did the multiplication. So let's combine these. Well, negative 18x plus 18x cancels. 14y minus 14y cancels. So 0 equals 2 minus 20 is negative 18. Can 0 ever equal negative 18? No. Think back to when we solved linear equations. If you got two unequal numbers, your answer is no solution. So if you try to cancel or eliminate one of the variables, x or y, and this happens, then your answer is no solution. Let's take a look at a final example. So first, let's start by writing our system. Negative 14x minus 16y equals 24. And I've got negative 7x minus 8y equals 12. So looking at this, I'm going to focus on the x's to eliminate. If I multiply that by a negative 2, I'll get a positive 14. So I'm going to choose to multiply everything by negative 2. So let's rewrite. Negative 14x minus 16y equals 24. And then we're going to do our distributive property here and here. So negative 2 times negative 7x is positive 14x. Negative 2 times negative 8y is positive 16y. And negative 2 times 12 is negative 24. So now let's combine our two equations. Negative 14x plus 14x cancels. Negative 16y plus 16y cancels. So if everything on a side cancels, you write 0. Well, what is 24 minus 24? It is also 0. How often does 0 equal 0? Always. Always. So if you have, again, just like in our first few weeks of school, if both sides are equal, then you have infinite or many solutions. Okay? So a quick reminder, to eliminate, you choose one of the variables, multiply one or both of the systems by something to get opposite coefficients to get that to cancel. But then remember, you go back and substitute in your whichever variable you didn't find or did find to get the other. And also remember your special cases. If you get two unequal numbers, your final answer is no solution. If you get two equal numbers, then your answer is infinite or infinitely many solutions. Make sure you show your work on your practice, guys. No work on the practice tells me you used your calculator, and the most you can get on that is a 50. So make sure you show your steps. I'll talk to you guys later. Bye.